Hello, listeners, and welcome to another episode of Get Smarter, an LCE podcast series. Today, I've got a really special guest for you. We have Art Sorak. He's a senior reliability engineering subject matter expert here at LCE. He's an engineer and an MBA. He's a Six Sigma black belt, and he's got more than 30 years experience in manufacturing, in the manufacturing industry. He's made some significant accomplishments, one of which is that he is an ISO lead auditor. So Art, I just want to welcome you to the podcast today. Thanks for joining us.
Thanks. I'm glad to be here.
We came up with this idea to interview you today. We're calling it the best kept secrets of a reliability engineer. So I'm really happy and excited to talk to you today about being an RE in industry and sharing some of your experience. So let's jump in. Our first question. As an experienced reliability engineer, you've built programs on your own for reliability and asset management. And now with lifecycle engineering, you're helping others to build their asset management and reliability programs. So if a new reliability engineer wants to make a big impact quickly, what are some of the first three things that they should do?
Well, the first thing they need to do is obviously, if they're new, they need to get to know the plant, but they also need to get to know the maintenance guys, the
Oh,
guys who
yeah.
are working on the equipment. So get to know your maintenance supervisor, get to know
Mm-hmm.
some of the senior mechanics,
Mm-hmm.
because if you're making changes, you're going to be asking them to change the way they do things. So you want to have them on your side, and plus they know a lot about the equipment. They know a lot about what really goes on. And then the other thing they need to do is talk to the operators. So when they're getting into an equipment problem, go out and talk to the operators who use the equipment,
Right. The asset owners, right?
right, the asset owners who operate the equipment. Then the really, to me, the most important thing is there's never a shortage of problems in the plant. So the key is to prioritize. Okay. And the way you do that, how do you prioritize? So you you use the that's in your system. So what we call it, to go in, understand what's happening in your area, and what
Okay.
you're looking for is repetitive issues. So the big black swans occur now and then, and you're going to have to address those. But there's things that happen in your plant over and over and over again, and they each as a single incident might be a small production loss, but
Mm-hmm.
as a whole, over the course of a year or 6 months, they add up to a big loss.
Right. They're
So
chronic problems.
they're chronic problems, right? So we want to understand what the chronic problems in the plant are, identify maybe the top 10, and then working with operations, agree on what the top 2 or 3 problems we want to go after.
That's that priority you're talking about.
Right. That's prioritized. So we can address 2 or 3 things at the same time,
Mm-hmm.
right? But we want to agree that those are the priorities, and then start understanding what the problems are. And the tool we use for that is root cause analysis. So you need to become familiar with root cause analysis methods,
Right.
either as a group or even just by yourself, understanding what's going on with this equipment, right?
Mm-hmm.
So, uh, and as we start to understand what's causing the problems, and then putting in place corrective actions, uh, we monitor those problems to see if our corrective actions are making a difference.
That's verification.
Verification, right? What is it? DMAIC, right? Define, measure, analyze, improve, control, right?
Exactly,
So
exactly.
once you're
I knew you
in,
were going to bring in some of that Six Sigma black belt.
once you have a potential improvement and you implement it, and you might have to go through change management or whatever, but you're going to implement that and see if it works, and then monitor it the same way you with the same data that you use to find it, right?
Identify the problem, right?
And once you start to see that you're making an impact on that, then we can talk about control plan. How, maybe there's a PM or a procedure you need to write that needs to go in the system so it's repeatable. Or if it's a modification, then we need to record that modification in our equipment data. But that's your sort of your control.
Right.
But then you have that to do. But once you start to see an impact, then you can start moving down your list. So you identify the top 10, and okay, we can sort of check that one off and say, yeah, okay, we'll keep looking at it, and now we can
Winning.
right, exactly, and then you can move to the next item on your list. And then the other thing that you want to do is look for common causes in your plan.
Oh, that's
So,
interesting.
so maybe the solution you put in place for that particular machine will solve problems on other machines.
I see. So,
So we were just working with a client, and it
hmm
was on a particular packaging machine, and they have 3 baggers on this line, and we analyzed the data for the line and found that the baggers had a problem. So we used some keyword searches and things like that within the work order data, and we found a particular keyword, and we went after that and to understand what the problem was. So the
hmm
keyword was knife, and it was it's just a knife that cuts the bag. But the engineer looked at the problem, and we were thinking, oh, maybe they substituted the wrong material for the knife, or,
hmm
but it turned out it wasn't a knife problem at all. This is just how the operators understood it. So they were putting the data, the work orders in and saying, we're having a problem with the knife. And
Ah,
the problem was the mechanism that the knife is on was out of tolerance. So it had um, bolts instead of pins. It had the wrong parts put in. And so we ordered the right parts, rebuilt the mechanisms on the 3 baggers, and it solved the
hmm
problem. Okay. Now, um, now the mechanism was um, hitting the mark, and the knife wasn't
hmm
jamming or getting damaged anymore. Now that same solution worked on another line that used an identical bagger. And so we hadn't looked at that line. We hadn't identified that line as a priority, but it solved the problem over there too. So we solved the problem on these 3 machines, and it actually solved the problem on 6. Another example of that from my own past experience was when I took over maintenance at a plant, and I would come in every morning and look at the log books from overnight. And I kept every day, I'd read coupling, coupling, replace coupling. Um, and now the plant had 900 pumps, so there were 900 couplings.
right.
And so we had, just I just noticed it as a pattern, and
Yes,
then
a trend.
it's
Yeah.
a trend, right? And so it wasn't a particular machine, but it was a very common problem. And so, shortly after that, I was looking at a issue with one of the maintenance supervisors. And I said, by the way, once we get that motor in place on this fan, how do you align it? And he said, straight edge.
Mhm.
So a straight edge, you can, you can align a coupling with a straight edge and a feeler gauge, but it's not going to be, that's not precision, right?
Right.
It's close, but yeah, you might, a few guys can probably do a good job with that, but most guys were not, right? So we're just kind of, hey, looks good. And so over the course of the next year or so, we purchased some laser alignment kits or laser alignment tools for the maintenance shops, and we put
Uh-huh.
every guy through training. And and so this took time to implement, but this was a real common cause problem. So it was a precision maintenance, instilling precision maintenance, and over a period of time, we started seeing our
Yeah,
coupling problems go away. Right.
that's a big impact. And
Yeah.
that's what we were talking about, if you're going to make changes, if you're going to make improvements, I think that's an excellent approach that you're giving. So the reliability engineer is making everybody's life better, right? Is
Right.
solving these problems, but it does take, um, as you said, it takes investment, in time, and commitment, for the training, and to take the time that you need to make the impacts that you can, and money, but also that change management. So we've been talking about a lot of things, like about finding bad actors, about loss elimination, root cause analysis. We just started to talk a little bit about precision maintenance. I mean, what are some other essential, like, methodologies or frameworks that reliability engineers should become familiar with?
So really, the what I talked about previously just leads right into precision maintenance.
Yeah.
So there's a number of things depending on what kind of plant you're running. And I came from a chemical background, so lots of rotating equipment, lots of pumps and things like that, belt-driven equipment, and but you might
That's
come
ripe
from
for vibration issues, right?
right. Oh, totally. So, but we were, so yes, I can take my vibration analysis out there and measure the vibration, but I can, if I use precision methods,
Hmm.
I, you know, I can prevent that vibration from occurring. Right? There's always a forcing function for any vibration. And so, that misalignment and rotating equipment is a key thing, right? So we want to we want to maximize the alignment, which minimizes the vibration. And then talking about the coupling problems, that same vibration is also um, putting wear and tear on the bearings, and it's
Sure.
putting wear and tear on the mechanical seal of a pump. So, mechanical seals usually don't fail from being worn out, right? They fail from some other cause.
Right.
So, there's other things you can, so, in looking at your bad actors,
Hmm.
it's really beneficial to, if you can, focus on common cause issues. So,
Sure.
determine
Those
what
are
those
those are
common
easier to
causes
make the
are.
business case for, right? And
Yes.
I mean, and I think you're talking about more than just laser alignment. I mean, you're talking about culture change here, is what I'm hearing.
It,
Would you
it
agree?
really is. So a big one in my past and in my experience working with the clients too is
Hmm.
belt, just ordinary V belts, right? And so on V belt, it's very common. A fan might have 3 or 4 V-belts on it. So we get a call that the belts are smoking or the belts are squealing or they're, or the machine's not turning because the belts broke. And we go out there and we cut off the old belts and we roll on some new belts. And when you roll on new belts, you're already damaging the fibers, the reinforcing fibers inside the belts. So
You've already got degradation from.
You've already degraded brand new belts.
Yep.
And so, we should be loosening, say, the motor bays, and then installing the belts, and then tensioning them correctly and measuring them. And we should be aligning the shivs.
That's what, yes.
Right. So there's really simple ways to do that now. I mean, they've been around a long time. There's laser tools that will attach with magnets or on the front of the shivs or in the grooves of the shivs, and will make it easy to align the shivs, both by offset and by angle. I mean, you can always do it the old way and run a string and, use a straight edge, but that's, it worked a long time.
It's not as precise, right?
It's not as precise, but the lasers make it easy. And anyway, and then the other thing is every time I pull that guard off to work on the belts,
right,
it's an opportunity for me to inspect the shivs. So the shivs, V-belt shivs, wear, the grooves wear, and so over time, the belts might sit deeper in the shivs, or that they have less contact with the belts, less friction contact. So there's a set of simple gauges that you can put in the groove and look and see if the sides of the shiv grooves are worn. And if they are, then you probably don't have those shivs in stock, but you can take some identification marks or measure the diameters of the shivs, write it on to the work order, and create a work order to replace the shivs.
That's right.
Right. So, so one of the things you can do is create a job plan on changing belts, right? So that every time we change a belt, we follow the same procedures, right?
Standardization, and also
standardization, but it's a good time-tested procedure. There's plenty of resources from the Gates or the other belt manufacturers to help you to do that, and you can create a document that says this is how we do it, right?
Right.
And then you have to train guys and you have to set the expectation.
Yep. It's back to that it's back to that commitment, that that attention to the details, that need for standardization, that training aspect. Here's the expectation. This is how we're going to treat the equipment. We're going to write those corrective work orders when we need to. When if we find issues when we're working on something. I think that's great, and I love that we've talked about these different methods kind of over time. So I want you to kind of put your fortune teller hat on, and I want you to think about the role of the reliability engineer just in your time, how that has changed, right? But what do you think is coming next? How do you, just in your opinion, how do you envision the role of a reliability engineer, kind of evolving over the next 5 to 10 years? I mean, about decision coincidence, but we've also visited some tried and trues, of, using string or I've heard something, and we might have to talk about this later. I might have to bring it onto a different episode, but I know that somebody has told me something to work with gear and a piece of white bread, sandwich bread, but we could talk about that another time.
I
So,
might
but
not know
what
that
about
trick.
there's
Oh,
I've got
beers
to
and bread. Oh, like a clearance. Oh, I like that.
no,
I got to hear
I
that. I haven't heard that one. Yeah.
I've got to I need to go back to my source, but I'm going to bring it back in another episode, so stay tuned, listeners. But how do you see the role of the reliability engineer evolving as all these new technologies and
Well,
opportunities are available?
that's that's really it's almost hard to keep up with, right? I've been in the business a long time. I came from single channel analyzers, and just having a dual channel vibration analyzer was a revelation to me, right? I can I don't have to shut the machine down and put a mark on it with it so I can use a strobe
Or
to
what about the screwdriver?
well, you know right, the screwdriver is an interesting thing because uh right you don't want to write a procedure that says go listen to it with a screwdriver, but the screwdriver does work if
It
you're trying to
works.
diagnose something, right? Yeah, I can listen to a steam trap and right, but there's
Absolutely.
so many more advanced methods now, and so uh, it was probably the uh, 90s, when a dual channel analyzer, early 90s, I guess, when the dual channel analyzer came out, or at
Hmm.
least when I first used it. But now you've got so much that you can do with continuous measurement. So the, infrared, measuring infrared's a great tool for electrical systems and thermal systems, and really just every day, all kinds of machinery to diagnose. But the rate of technology improvement in infrared, it went from being this huge shoulder mounted uh, you know rig that you had to charge with liquid nitrogen, to now you can just get a really pretty good infrared thing and just attach it to your phone. So
Oh,
uh,
that's cool.
yeah, but for a reasonable investment, I can get a really good vibrate thermal imaging system, um, that will you know integrate it with still pictures and just give me just the amount of data I can get out of that is just astounding now. The way it's changed over the years, and to the point where thermal imaging can be installed uh, on a panel, on an electrical panel, to monitor
Hmm.
something full time, and it's
Continuous monitoring. Hmm.
continuous monitoring of it using infrared, right? Um, I mean, we've had continuous vibration analysis for a long time, but the price of the infrared has come down so much, and the capabilities has increased so much, you know, that you can just, especially on critical equipment or equipment that you can't really get to when it's under load. Um,
It can be a real
continuous infrared is a
advantage.
real
Yeah.
advantage, right? And I can radio transmit that out and look at it anytime I want to.
That's a lot of data, though. So, the role of the reliability engineer, though, is data, right? I mean,
Yes. So, and
yeah.
the other great thing that's really just emerging is
Hmm.
AI.
Yes.
So we've had artificial intelligence. You could call it artificial intelligence built into vibration. So I can, take my vibrations. The vibration software for a long time has been able to look at the FFT and to determine, give you suggestions, right? And so
Okay.
that's getting much more powerful,
Hmm.
is to be able to analyze. So one of the equipments I'm working on right now is an automated storage and retrieval system, and it's carrying very heavy items. And when that's under load, right, when that's operating, it's variable speed and variable load. So it's much more difficult for conventional vibration analysis. But with the new models, um, you know, we can improve our capability to understand where our alarm limits should be with that equipment. And furthermore, I already mentioned the continuous infrared. So the main breaker
Right.
on that, the main breaker of that system is behind, a rack, and I cannot send a man in there when it's under
No.
load to do vibration, or
Right.
to do vibration or to do infrared, right? So I already know I can install, vibration sensors on
Hmm.
the equipment, but the main breaker or the power panel or any of that, I can now install um, continuous infrared. So I'm looking for issues there. So, and then just set up a frequency where I can monitor that.
So it's just so much more accessible now,
Yes,
than it used to be. It's almost like, um, you know, a no-brainer to how to use all the technology if you can, again, to predict, those failures so you can have time to plan and schedule your work, right?
right, right,
And get the parts you need if you need to
right.
do that.
It's creating it's lengthening the amount of time I have to react to a failure. So the early detection gives you a longer planning horizon before
Yes,
you actually have a functional failure.
the maintenance window.
The maintenance window.
That's what we call it, right? I like to look through that maintenance window. One of my favorite curves, the PF curve. Now I guess we call it the DIPF curve. But it's in a lot of our training materials.
Yes, right,
And you guys use that on site too, to explain the importance of and the interconnectivity, right?
right.
Between um, reliability engineering and work management and Storim, as the partners,
I
right?
have like 6 different versions of a PF curve on my drive, just to be able, you can show, okay, this is where on the curve these technologies, you know,
Yes,
will be, and
will
uh,
be most
there's
effective.
just all kinds of ways to look at it. But when you get that up in front of people and explain it to them, and you say, where on this curve do you want to live, right? Do you want to live where it drops off and there's a big explosion, a
There's a
train wreck,
big kabow, like
right?
now,
It's
definitely.
I'm always amazed that so many people are still fix it when it breaks, and they're not in control of their plan. Their plan is in control of them, and we want to, uh, right, when we
Yeah.
use good methods to
Hmm.
put things back together, and then we use good preventive and predictive technologies, we stay ahead of things, right?
Absolutely.
If I come and ask you, what is the condition of this machine, you should be able to tell me, right?
Right. Well, I mean, and that's what that's what you do. You're out there helping people see the light. It doesn't have to be that way. There is a
Right.
better way,
It
you
doesn't
know?
have to be that way. And really it's a combination of work management. So you have to get, the data that a reliability engineer relies on comes from uh, really two sources, right? One is the work order system.
Work order
So,
system.
and then second is operations data. So if they're measuring OEE or something like it, right? Then
Yeah.
we want to look at that data because that's telling us what our losses are, right?
Where are your
I operate.
problems?
You can do an awful lot with just the maintenance data. So,
Yeah.
um,
Well, I mean, I think that that is a good thing for our listeners to hold on to. You can do a lot with the data that you have, right? You
right.
just and should give people hope that, you know, you can find those bad actors and you can start attacking the problems that make your life, you know, in the site miserable.
Right.
So
But
let's
you
talk a
have to
little.
record it. You have to write a work order for every problem.
Every problem so that you can see the history and that you
That's
can trend
exactly
the
right.
problems. So it's
Exactly
that
right.
discipline that we were talking about again. And I want to ask you though, since we're going down this, you know, road of you being a trusted advisor, you know, a consultant that a subject matter expert that that helps our industrial clients out there. If you were to go back in time and could give yourself a piece of advice, um, you know, in your career as a reliability engineer, what of advice um, would you give to to a, a a new engineer, somebody who's just starting out?
So some of the things we talked about earlier were,
Hmm.
um, you know, talking to the people in the plant, right, and
Right.
gaining knowledge because you come in with a good, uh, you might come in with some good experience or whatever. One of the things that I wish that I had when I was 25 was an education in the best practice of a work order management system
Okay.
and and a and a, and then all the process flow for a reliability engineer and the tool and the knowledge of the tools, right? So, you know, we offer that education. It's a great thing. So
So
I
give
had,
me an example of the tools, because I know in our when we think about reliability engineering standard work, we've got, you know, your data. You want to get your asset data collection. You want to do your hierarchy and your criticality. Root cause is one of those. You know, processes. What
so
kind of
I
tool
was really
examples would you give?
referring to as a foundation. So once you was the you know step by step in work management,
In work
right?
management?
So in step by step in work management is identifying the problem, creating the work order, right?
Right.
Planning, how
Approving
important
it?
planning
Yeah.
is, right?
Uh-huh.
Uh,
Right.
Planning and scheduling, working, you know, communicating with operations, uh, and creating that schedule, and
Maintenance schedule with production. Yeah.
executing the work, and then doing a good job closing it out, putting failure codes in, putting things as found. You know, so the problem was identified as it's not working right. Okay, what did we find? What did we fix? What did we do? Right, and so that right, and then from the reliability engineers aspect, the process flow includes you know, understanding or getting all the data for a piece of equipment in the system, understanding the criticality of your equipment, and then the tools. So once I have all that, you know what using the right tools to establish your maintenance plan, and then all the continuous improvement tools. So the uh, preventive maintenance optimization, how to write a good PM plan, a good job plan, and then and what we talked about before was uh, the bad actor or addressing the chronic issues, right? So with root cause
Right.
analysis. So
Could
it
you
you know it was just as when I was later in my career and I had all this experience, and then you start looking at these processes and you say, man, I wish I knew this stuff, to start with, right?
Well, I think that's great because you're talking about this story. When you're describing, the work management process, and the work order closeout, it's really telling the story. It's telling the
Right,
story of your site. It's telling the story of your operations, and just that tight integration um, between equipment, reliability engineering practices, and your work management
right.
practices. That is just so important, I think, for people to understand. And I really appreciate what you said about, you know, get that foundational knowledge, that foundational training of best practices across the key areas, of plant um, operations, which is, reliability, work management, materials, right? Your storeroom.
Right. And I'll
Um,
put a plug in for Smarter,
oh, yay, the smarter playbook.
because
That
if
has
you
it
have,
all.
right,
It has it all,
the
right?
Smarter has it all in there. You have to spend the time, but we also, we offer, there's trainings within Smarter, so
Mm-hmm.
you can do a good training on root cause analysis or
Or
on,
reliability centered maintenance.
right, on reliability center maintenance, and so the key concepts are there. And then our class, then our live classes is also a great resource.
Yes, and the Life Cycle Institute. And I think with well, as part of this, we recently started adding certifications, right? And so that is a way for, a practitioner to really get that experience to work with subject matter experts like yourself, to do work products, that are not only educational tools, but they're also making a difference, right? They're making a
Right.
difference at the site, and they're showing the rest of the team that, hey, we can work together to solve these problems. It is going to change the way we do things, and we're going to get a better result.
So
We're
a
going to get a
big
better result.
boost to me, especially leading reliability, was going to SMRP conference.
Oh, that's another for the networking there and
It's
SMRP. Yeah.
fantastic for networking, and you're immersed in it for a couple of days, right?
Hmm.
Whether you go for
Hmm.
2 or 3 days, and they have classes and things like that you can take, but just to go walk the floor, see what technologies are out there, and then to
That's it.
go to the class, the seminars, the speakers uh, that they have. You know, to me, it was just I would come back brimming with ideas. And then, of course, I'd have to prioritize and cull those ideas
There you
down a little bit
go.
because you
Back to
can't
your
solve
key.
world hunger, right?
Right. You gotta prioritize. There's always going to be problems to solve, and that's why we need engineers. That's why we need reliability engineers like you. And I mean, we have talked about a lot today, but I think we've given our listeners a lot to think about. We've talked about the importance of prioritization, the importance of standardization, whether that be, in your parts, whether that be in how you do your work, how you approach your work, standard work practices, good methodologies, using good methodologies like RCA. But I also really appreciate what you're saying about, not only improving things and working on the bad actors, prioritizing, making changes where you need, but also getting out there in the community, right? Getting out there and going to conferences, seeking, professional development training, going to places where you can find out about new technology you can implement, that are accessible, that you can implement, that can really make a difference at your site. And I see you out there making a difference every day with our clients. So thank you for what you do, passing on your expertise.
Yeah.
The
Thank
tough love, I know that it has to be doled out sometimes.
I enjoy it. I get
Well,
it. I get a charge out of it. I mentioned that story of the packaging machine, right?
uh-huh.
And so, we used the work order data, right? So we had worked on doing a better job of writing work orders every time we had a problem, right? And we could go back 6 months and we mined that data, and that data pointed us to that knife issue, right? It was knives, but it was a knife issue, but it wasn't a knife issue,
But
right?
it wasn't a knife issue.
Right. So, but we went out and investigated, and when so I had, we had identified that, and we were with our reliability improvement team, with the operations people, and we identified that, and we all agreed that we need to go look at this. So the
Mhm.
reliability engineer. So while I was gone, right, the reliability engineer looked at it, and then I came back and I said, hey, what'd you find with that? And he had a little PowerPoint showing,
Oh,
this is,
nice.
yeah, yeah, with a little video in it, and just to show what he found. And I was so excited that, we just did some real reliability work, right? This was
There
great,
you go.
right? We identified our bad actors, and then we went after one of the top bad actors, and we found the problem, right? And we could
Mhm.
put in a solution, right? So it was great.
Right. I mean, it's making a difference. So, I just want to tell our listeners, you heard it here, folks. We got the secrets of a reliability engineer. And I've just had so much fun talking with you, Art. I hope you'll be able to come back and be a guest another time on our podcast.
Anytime. It was
So
fun.
thank you, Art. All right, and listen up, listeners. We're going to have some resources that we'll attach to the episode link that we're going to post for you. So I hope you've enjoyed and gotten some good nuggets of information from today's conversation with Art about the importance of partnerships, about the importance of prioritization. I want to think about another P, about the importance of precision maintenance. There we go. I got
Precision
three.
maintenance.
There we go. I got three. So we hope you'll join us again for another episode of Smarter Podcast. And until then, listeners, let's stay smarter, people.